Station, this is Houston. Are you ready for the event?
Houston, this is the International Space Station. We are ready for the event.
CNN, this is Mission Control Houston. Please call station for a voice check.
And good morning, station. This is Brooke Baldwin here at CNN. Can you hear me?
Hello, this is Mike Fossum on the space station. I can hear you. It's a little bit garbled, but I can make it out.
Well, hopefully you can hear me, Mike Fossum. This is a pleasure to meet you. Is this an okay connection?
Yes, it's an okay connection.
All right, roger that. Well, let's get rolling. I know you have a busy morning. Here's my question. It's so nice to meet you. You've been in space. You've been on the ISS since June. Do you miss gravity?
There are certainly times when you miss gravity, particularly when you drop something, when you lose something up here. On Earth, you get used to things that get away from you falling down by your feet, and so you'll look around the floor and in the immediate area. Up here, they don't fall down. They can fall in any direction, and they don't stop when they hit a surface. They're more likely to bounce than to lodge. So they can sometimes bounce a long ways, and that's a frustrating thing at times to chase down the stuff you lose.
Yeah, I guess you got to watch where you're looking. So, Mike, here's my question with regard to the ISS. I know you're one of 3 crew members up there right now. So far, Russia has grounded the Soyuz. They're working on a fix, hoping for a launch in a couple of days. If it's a no-go, how do you get home?
We're fine. We arrived on the Soyuz rocket in June, like you said, and the problem is with the boosters for launch, and there was a failure of that booster on one of the last launches of the Progress cargo, or it was a Progress cargo vehicle, but it launches on essentially the same rocket, the Soyuz rocket, the same one that we rode to orbit. We don't use that part of the rocket for the ride home. It's a much different game going home. So our ship is fine, and there are no similar components related to that failure for our ride home. So we'll be planning to go home in about a month, and there's no changes with that. What could change potentially is we're scheduled to have another cargo ship launch in a few days, and we're watching that very closely because it uses the Soyuz rocket, and that, of course, is in preparation for the next Soyuz launch in about 3 weeks, with the next 3-person crew to come up here and for us to get some handover time with them. So we're watching it very close. It's a tight schedule, but we're working hard to meet it up here and certainly on the ground.
Help us understand sort of morning, noon, and night, what sort of experiments you all are undergoing on the ISS that you can share.
Oh, sure. We could talk about that for a long time. There's a lot of different experiments that are going on all the time and around the clock. Some of the experiments involve us, and we're the guinea pigs here in the microgravity environment, and we're doing different exercise routines and medications to combat particularly bone loss, muscle atrophy, those kind of things, the deterioration of the cardiovascular system. And so we're the guinea pigs to look at that. Some of these are related to longer duration human space flight, like the trip to Mars we hope to make someday. And it's also related to bone loss, of course, and muscle atrophy, and those things are related to diseases and the progression of age on Earth. Up here, the aging process for our bones takes place in weeks and months instead of years. And so we're looking at the same kind of things that you know about on Earth for combating that. There are a lot of other experiments that go on, and they range from very interactive ones where we're involved with hands-on and eyes-on the experiment, basically the hands and eyes of the researchers on the ground. There's others where we essentially change out samples, where there's furnaces that are going on that are doing materials processing, and our job is to service those experiments. They're all closed and sealed during the actual conduct of the science experiment, but they need us up here to change out the samples, to change out the fuel canisters, and things like that, to start the plants growing, to clean out and reset the centrifuges, and those kind of things.
Okay, so given all of that, I imagine you're pretty busy up there, but I'm sure you can keep up what's happening back here on Earth with regard to the news, and we keep talking here at CNN about, weak economy, budget cuts. I covered the final space shuttle launch of the Atlantis a couple months ago at Kennedy. So with no longer a space shuttle program, how do we still instill a sense of, space and exploration in the hearts and minds of our youngsters?
Not just in the hearts and minds of the youngsters, but in all of the people of America and really around the world. Go outside and look up and watch us come over some evening, and it's marvelous to look at this facility that humans have built, and it's 15 countries from around the world working together very hard for many years, decades really, to design this space station and then to build it. And now we're up here. We're living here. We've been up here for 11 years around the clock. And with crew after crew, we're the 29th crew to run the space station. And it's an exciting thing. We've gone from assembling the world's largest and most complicated, certainly most complicated engineering project, is now operational in orbit around the Earth. And it's an amazing thing. There's a lot of great stuff. And it's really, today, this is where the exploration is taking place, in space, where humans are involved. We certainly have rovers on Mars that are still, giving us some results. We have probes that are, out beyond our solar system now, and there's a lot of exciting work there in the, in the unmanned work or the remote sensing kind of work. But here's where the humans are involved, and this is where the pioneering space, takes place, where we learn how to live and work in space for long periods of time. And it's an exciting time. I think we need to continue to tell that story, and I look forward to the years ahead. It is a sad thing to me and to most of us, I think, to see the space shuttle program come to an end, but it was time, and we have to come to grips with that. At the same time, we look forward to, there's a lot of different things on the table. It's a little bit confusing, certainly from here where I can't keep track of it on a daily basis, but I'm sure to everybody and to you who reports in the business, a little confusing on exactly where we're going. And I think we're trying different ideas right now. Some of them are led by the government, many of them are led by private enterprise. Certainly within months, private enterprise will start delivering cargo to the space station. We look forward to that with great anticipation. And there's a number of teams working on the next way of getting humans into space to deliver to the space station and serve as a lifeboat and a ride home to supplement our Soyuz capability that we have today.
Mike, I read that as a young boy you actually started a notebook writing about Mars. Do you think in your lifetime we'll see footprints on Mars?
Yes, I do. I've always believed that. I had hoped that I could be one of the people to help put those footprints there, and I still may. It won't be my footprints more than likely, but I think we will, because it's very compelling. It's hard. It's a real challenge. The moon is 3 days away. Mars is 6 to 8 months, depending on exactly how you get there. That's one way. And then you have to, do your work and turn around and come home. So a Mars trip's a 2-year mission, and the systems have to work. They have to work very reliably. And so part of what we're doing up here with closed loop, recycling our water to a very high percentage, that's the highest ever on a spacecraft, that's a big deal. That system has to operate flawlessly to and from Mars for a long trip like that. And so we're making ground. We're learning things from the International Space Station as a test bed for these kind of systems that are going to be crucial for a long trip to Mars, as well as the human aspect of it, keeping us healthy enough to endure the trip there, be healthy enough to get the work done when we arrive at Mars, and then get home.
Mike, that's all the time I get with you. I look forward to covering the day when we get to Mars. Pleasure to meet you. Thank you so much.
Thank you very much. I really appreciate it.
Station, this is Houston ACR. That concludes the CNN portion of the event. Please stand by for a voice check from MSNBC.
Highly reliable closed-loop system. Yeah. Commander Fossum,
Hey, greetings. Mike with you.
Mike, Dylan Radigan, thank you so much for some of your time, whatever time it is, wherever you may be right now.
Hey, Dylan, we're over the South Atlantic heading toward Africa right now. Great to talk to you.
What time is it? You're over the South Atlantic heading towards Africa, so what time was that? How do you keep time on that thing?
We work off of basically a universal time, or GMT, and so right now it's about 2 o'clock in the afternoon. It's just after our lunchtime. Keeping track by the sun doesn't make any sense when you go around the Earth in 90 minutes and you have a sunrise and a sunset during that time. So we work off a universal time like this. All
right, let's begin the interview, and if you don't mind, let's start right there. You were just educating me the way you keep time on an International Space Station. Educate us a little further. How do you do it, and how often does the sun rise and set in a given day for you?
Well, we're working with countries around the world, and we're going around the globe in 90 minutes. So we see a sunrise and a sunset within an hour and a half. So we can't keep track by the sun, and we had to set a time standard someplace because we all have to have a way of talking about it. And so we use GMT, Greenwich Mean Time, and that becomes our clock. So right now it's 2 o'clock in the afternoon for us up here. We get up at 6 o'clock in the morning. We really begin our work day about 8 o'clock in the morning in earnest, and we work until about 7 at night and go to bed around 9:30, 10 o'clock. So that's our clock, again, all based on GMT. And the control centers around the globe, Houston, Moscow, Munich, Tsukuba, Japan, all are working to that same clock, and so they're displaced in their local times. They may be coming into work at midnight to start the day and things like that. That's just one of the interesting aspects of working up here.
Yeah, so it's interesting, though, because if you work on the Earth, but you're associated with the space station, you work on space station time, not on Earth time. When you talk about the work, what specifically is it that you are working on, and why is developing a closed-loop, secure, stable space system so important?
We're working on a number of different things. Of course, there's a lot of the main reason we're here, the main reason the space station was built was to conduct the different science experiments that are ongoing right now. We have many of them that are ongoing. Some of them we're interacting with, some we're tending. We're changing out the samples while the scientists on the ground are running the furnaces, running the combustion chambers, things like that. Another thing that we're doing with the space station that's really huge, it's very interesting, is we're developing the systems for long duration operation in space. So the space station itself and its functioning systems are test beds. We're learning from these different systems. Right now in Earth orbit, somebody could theoretically get to us in, after about 9 minutes worth of launch, some rendezvous time. Usually it takes a couple of days, and we could have another ship here. If we're on the way to Mars, we don't have any way of getting parts up here quickly. And you have to go self-sufficient because nobody's going to be coming to help you out in any way. So we have to have systems that operate for a long period of time. One of the real limiting factors is, of course, everything's about the weight or the mass in space. Water weighs what water weighs, and you can only launch so much water. It's a kilogram per liter, and it's a lot. You can't dehydrate your water, and you can't put it in a foil pack. And so there's great advantages to recycling. You don't have powdered water. You don't have powdered water. You need to recycle as much of that water as possible. That's a fairly new system for us here on the U.S. part of the space station, where we actually recycle. We take most of the water out of urine waste, and the condensation from just our breathing and our sweating gets collected in the air conditioning system here as condensate. And this water, this recovered water, then is recycled, purified, certified, double checked, and then we drink it again. And that's really important. And this kind of a system, it has to work flawlessly. Up here, of course, we check it a lot, and we have some options. We can go without purifying water for months if we needed to. We have supplies on board. But if we're on the way to Mars, that kind of a system needs to work without getting, some kind of bugs in it or microbial growth in it that really knocks the system out of whack. So we're a test bed for systems like that, too.
Are you anticipating, with your awareness of the current science and the current ability, that in our lifetime we will see a manned mission to another planet?
I'm convinced that I will see, human footprints on Mars. I dreamed about helping put those footprints there one day. I don't think that's likely to line up right now, but I still think we're going to see it. It's very compelling. Mars is just fascinating for so many reasons. We know fairly certainly Mars used to have liquid water. If it used to have liquid water, it used to have an atmosphere. It's got to in order for the water to be liquid, or it just boils off. It no longer has liquid water on the surface. It no longer has a significant amount of atmosphere. What happened? What changed? That's important for us to know. I mean, there's a scientific curiosity of understanding these things better, but it's also, I think, important because talk about, global climate change on Mars. Wow, there used to be enough atmosphere to support water, and there no longer is. That was a very big change. Be very interesting, very useful to know what caused that kind of a change to a planet.
Stunning. I mean, it's just stunning to have that as an opportunity and as a mission. You carry, obviously, so many people's, I think, curiosity and desire to answer those questions with you. We're privileged to have you doing what you're doing. In the practical sense, you have been getting back and forth, or not just you, but other astronauts like yourself have been getting back and forth using the Russian Soyuz rockets, which I know one of those had a failure, a cargo rocket, an unmanned cargo rocket had a failure in August. What is your degree of confidence in that system, and what is your view on the alternatives for Earth to space transportation?
The Soyuz launch system has hundreds of launches, successful launches. This is Mike's personal opinion. I'm not tied in with the technical details of what's going on with the investigations and the forward work here, but I have to believe from my experience as an engineer that we're not talking about a fundamental design flaw here. We're probably talking about a mistake that was made in the processing. You've got equipment can fail. You have but more importantly, you have people, and anytime you have people in the loop, humans do make failures. We double check, we check each other and those kind of things, but something still eventually happens when you have hundreds of launches. And my guess is it's a guess that it was probably something along those lines. I think these next launches are going to be some of the safest, most highly successful launches of the program, because the extra scrutinies on some of those details that may have escaped during the last launch flow processing. So I think we're in good shape. It is a strange thing for me and for all of us now to be riding on a Russian rocket to space. I mean, what an amazing thing. That wasn't even comprehensible. I dreamed about walking on Mars someday as a kid. I sure never dreamed about launching in a Russian rocket. That's beyond dreams.
That's, I guess, why we only control our intentions. We never know what the outcomes will be, Commander. Thank you so much for your time this afternoon. Enjoy the next sunrise and sunset, sir.
I will, Dylan. Thank you very much. A lot of great questions. I really enjoyed talking to you today.
Station, this is Houston ACR. Thank you. That concludes the event.
Thank you, CNN and MSNBC. Station, we are now resuming our operational comm.